Alrighty, everyone. So now for the final section in 5.6, it's about like distance, rate, proportional problems. So for example 1, it's a word problem. So what do we do for a word problem? We're going to read it through. So a rowing team rowed 60 miles while going with the current in the same amount of time as it took to row 30 miles going against the current. The rate of the current was 3 miles per hour. Find the rate of the rowing team in still water. Okay. So now that we've read it through, now let's highlight some of the important information. So what's important is 60 miles going with the current, okay, and in the same amount of time it took to row 30 miles going against the current. So the rate of the current, 3 miles per hour. Okay, and what is our goal? Our goal is to find the rate of the rowing team in still water. Okay, so what we want to do is we want to establish the unknown. So our goal is to find the rate of the rowing team in still water. So I'm going to say X. I'm going to define X as the rate in still water. Right? So now, looking at the title, we already know that it's a distance, rate, or time problem. But how do we know that? Like, for example, if we weren't given the topic, how do I know? It's because I'm given a distance. So the distance, we have 60 miles, we have 30 miles, and then we have a rate. Okay, and technically what we don't know is the time, but we kind of know because it's the same amount. So how do I set this up? How do I find the rate in still water? So for example, let's make a table. The table will be, I'm going to say with current, okay, and this is going to be against. Okay, so the very first thing it says, with the current, we have 60 miles. So what is 60 miles? That is a distance. Okay, so this is 60 miles. Okay, when you're going against the current, it is 30 miles. Okay, put over here. Right, what else do we know? We know the rate. So it says that when you're going with the current, what does that mean? When you go with the current, it is the rate you would be in still water plus 3, because the rate of the current is 3. Right. Okay, so this is X plus 3, and then technically this is miles per hour. Okay, when you go against the current, it takes, if you put the same amount of energy, you're still going to go slower. So this is going to be X minus 3 miles per hour. Okay, again, why is this 3? It's because the rate of the current is 3 miles per hour. Right? And what do we know about time? Let me extend this here. What is time? Okay, so we know that with the current and against the current, these take the same amount of time. So for example, with current, what am I going to do? I'm going to recall distance, rate, and time. It is D equals RT. I know the distance, which is 60. I know the rate, which is X plus 3. And then we don't know T. So what is T? T is 60 over X plus 3. Okay. And this is with current. So the time is 60 over X plus 3. Okay. And now we're going to go against. Okay. So again, we're still going to use D equals RT. Right? We know 30 miles. Actually, we don't need to put that part. So this is 30. What is my rate? Our rate is X minus 3 and then T. So what is T? T is 30 over X minus 3. Okay. So now the big question, how do we solve for the rate of the rowing team in still water. Since we know that this is the same amount of time, so it's kind of like the substitution, we can set these t's equal to each other. So what am I going to do? I'm going to take this 60 over x plus 3. This is the same as 30x minus 3. Right? And so now we have a proportion problem. So in this case, we're going to do the cross product because I have variables in both, so it can't really be easily solved. If you want to do the solving the rational equations, you're more than welcome to. I'm just going to do the cross product. So what is that? That is going to be 60 x minus 3. This is equal to 30 x minus 3. Right? Before I continue, I almost forgot, we do have to establish when is this undefined. This is undefined when x is equal to negative 3 and positive 3. Right? So now let's continue solving. So let's distribute. So 60 times x is 60x. 60 times negative 3. So actually, now that I'm solving this, when I look at this, instead of distributing these big numbers and having to deal with it, I noticed 60 and 30, they are multiples of each other. So what am I going to do to make our lives a little easier? I am going to divide both sides by 30. So when I do that, I get 60 divided by 30. That is 2, and then x minus 3. So take that. And then 30 divided by 30 is 1. So I'm just left with, this is x plus 3. So then we're left with 1 times x plus 3. I'm going to bring my work over here because I'm running out of space. So how do we solve for x? We have to distribute this first. So 2 times x is 2x. 2 times negative 3 is negative 6. And that is equal to, and then since there's a positive 1 here, when we distribute that 1, we're still left with x plus 3. Right? I'm going to subtract x from both sides. When I do that, I get x, and this is x minus 6 is equal to 3. Right? I'm going to add 6 to both sides, so this is x is equal to 9. Right? I'm going to do a quick check. 9 is not equal to negative 3, and 9 is not equal to 3. What does that mean? That means, let's go back up to our question. It says, find the rate of the rowing team in still water. So to answer the question, the rate of the rowing team in still water is 9, and we cannot forget our our labeling. So what is our labeling? It is 9 miles per hour. Right? And this is how fast they're going without any assistance or hardship. Now on to the second example. So now, first we have to read it. So a passenger train traveled 110 miles in the same amount of time it took a freight train to travel 90 miles. The rate of the freight train was 10 miles per hour slower than the rate of the passenger train. Find the rate of the passenger train. So what's important? So a passenger train, it traveled 110 miles in the same amount of time. It took a freight train to travel 90 miles. The rate of the freight train was 10 miles per hour slower than the rate of the passenger train. And then our goal is to find the rate of the passenger train. So before we do anything, let's establish our variable. So I'm going to use x again, and x is rate of the passenger train. Right? So now, how are we going to solve our problem? So I'm going to make a table again. So what are the two types of trains we're dealing with? We're dealing with passenger trains, and we're also dealing with freight I know this is a distance, rate, time problem because it tells me distance, it tells me rate, and it also talks about time. So first, let's talk about the distance. I'm just going to denote it as D. So the passenger train, they traveled 110 miles, and the freight train, it traveled 90 miles. Right. What is the rate? So let's see. It says the rate of the freight train is 10 miles per hour slower than the rate of the passenger train. So for the passenger train, it is just X. And then this one, since the freight train is slower, it's going to be the rate of the freight train minus 10 miles per hour. Okay, and I'll just put MPH here. Okay, so what is the time? So recall distance equals rate times time. So to solve for t, divide r by both sides. So it's distance over the rate. So time over here, this is 110 over x. And over here, this is 90 over x minus 10, right? Because it's d over r. Right? So what do? So now we know that for the distance and the rate, it took the same amount of time. So what can I do? I can set these equal to each other. So what do I get? I get 110 over x, and this is the same. This is equal to 90 over x minus 10. Right? Before we solve, we have to determine when is this undefined. Okay. It is undefined when the denominator is equal to 0. So it's undefined when x is equal to 0 and when x is 10. Right? So now let's solve. So I'm going to use the cross product. So 110 times x minus 10. This is equal to 90x. Right? Instead of dealing with big numbers, I noticed 110 and 90, they both have 10, a common factor of 10. So if I divide 10 from both sides, I get 11, and then x minus 10, and then 90 divided by 10 is 9x. Okay, so now let's keep solving. This is 11x minus 110. This is equal to 9x. Before I continue, I really want to emphasize that I noticed that these have a 10 in common, but if you don't see that, that's perfectly fine, because you can still distribute this and get 110x minus 1,100 and still solve for it. I'm just thinking I don't want to deal with big numbers, so I'm going to see if I can reduce anything first. Right? But if you don't, you're not doing anything wrong. Right, so now let's continue. To do this, I'm going to subtract 11x from both sides. So what does that give me? This gives me negative 110. 9x minus 11x, that is negative 2x. And now I'm going to divide both sides by negative 2. So negative divided by negative is a positive. So I get 110 over 2 over x. They're both even, so that means 110 is divisible by 2. So 110 divided by 2, that is 55. Okay. So what does this tell us? The rate of the passenger train is 55, and keep in mind it is miles per hour. Okay. And this is our answer.